Hello everyone, this is Blender Gabi. In this video, I'm going to demo the creative flow and the random flow add-ons. So I'm going to make or demonstrate to you the way I create those guns from a simple plane using creative flow at first, then detailing with random flow. And we're going to use creative flow to draw on a simple plane. Draw the shape of the gun, then create thickness for it, then separate it in different sections and give it different thickness to give it dimension. And then we're going to fix the topology, and then hopefully we can use random flow to detail it. Okay, so let's delete this and create a plane. So this is the y-axis. We're facing the y-axis right now, so we need to be on the side, and we're going to rotate it in using the front. So rotate it in 90 degrees, or you can press R and then in the numpad 90. And then we have this. Okay, so let's just try a symmetrical gun and auto mirror. I'm going to place the real geometry on this side here and just mirror it in the z-axis. We can't mirror it in this x-axis because there's no thickness to this. And we're going to draw the gun here, and we're going to make it, yes, I'm more comfortable drawing it towards that direction, so I'm going to draw it that way. But you can of course do it towards that if you want. Okay, draw cuts. Just a simple. So when you're drawing, if you want to use the polygonal, just press number 2. You can see the draw shape 3 is circle, 4 is strips, and 1 is box, 2 is polygonal. When you're drawing, you can press Shift to make it snap to 45 degrees, which you can change using the snap angle, left and right arrow. So 45 degrees, 40. So it's set to increase and decrease in the 5 degree intervals. Okay. And yeah. So shift to snap from the last point and out to snap the last point to the first point. So you can also press shift and out. So shift to snap from the last point and out to snap from to snap the last point to the shift to snap from the previous point using the last point, and then out is used to snap the last point to the first point. So you can of course combine the two hotkeys. And by the way, this strips right here is in the next update. If you don't have this yet, so this just means that in your version, the last line is considered is the last line is included in the drawing. So that means you have to hold the position of the last point and then press space. So it won't work right now because of the changes I made. So essentially, hold the last point and then you can actually, I'm using shift to snap to the previous point, then out to snap to the first point. And I can release the two hotkeys, and by not moving the mouse, I press space, and then I get the rectangle shape. But in the next version, which you have this strips, this is signifying the last line that you made. So making the something like this is easier right now because the last point will not be included. So the strip right here is indicating the last line that you made. So it's much easier now. And that will be in the next version. Okay, let's draw the gun. So I'm pressing shift right now. Okay, that's the last point. So in your version, you should hold this and press space. You can let go of the shift alt and do not move the mouse and then press space. So, but in my version, I can just do this. Now we have the shape of the gun. And then I'm going to create a thickness for this in the X direction. Yeah, because the faces are facing towards the X direction. So draw modifiers, use solidify. The mirror is already checked because this is using a mirror. And then the thickness, to how much thickness your gun should have. So a little warning that this design will be mostly angular because making curved design will take much more time. Okay, so it's up to you to make it less angular. But I'm just going to show you the workflow involved. Okay, you can use draw cuts. We can use draw cuts to create sections for this, and then we can separate it. Then press P after, and draw modifiers, give it different thickness. As you can see, the thickness of this, we cannot adjust all of the vertices because the thickness is provided by a modifier. And in order for us to touch the other vertices, we need to apply this bunch here, Control A, and then we can touch the other modifiers. Or you can use the apply mesh. But for now, we're going to with these modifiers in these objects, we're going to cut the mesh and separate design pieces. Oh, that is the mirror geometry, so I should have drawn on the real geometry. Another important um, detail to remember. P and separate the selection. So without the actually without the viewport cavity and the outline, we really cannot see the separation between these parts. We can see the separation between this and this when we look at it in different angle, but between this and this, there's no clear separation. So what do you do to make it obvious without affecting the thickness? Well, you can um, create micro bevels for each add a bevel to each of the object. Micro bevel, use bevel modifier, harden normals. So in order for this to work, we need to auto smooth the two objects. There. Now the separation is much more obvious. So we're just going to remove this first because we don't need the bevel for now. I'm just going to use the um what is it? Cavity and outline to make everything light in the start. I mean at the start. So you don't have to follow the exact movements I'm making. Just you can also create your own design and just follow the workflow. So I need the thickness of this for this. So I need them to be at the same thickness. So I select this, draw modifiers, and then let's say this is 1.12. Control C. Hover the mouse cursor over the property and Control C. And go do here and draw modifiers, Control V. Oh, it's already 1.2. 0.12. Okay. But just in case, so if you have this thickness like that, for example, Control V, and now they have the same thickness. And we're also going to adjust this. We can also cut this. And we can also subtract from this the drawing. I mean, oh yeah, this the last point is not included. Like that. And then we can fix the topology. Let's use quad slice. What it does is the quad slice. What it does is create uh, a line from the verts, and tangent means we're going to be using the directions of the edges for the direction of the cuts. So, for example, tangent. So this property here, when we scroll it, when we use hover over the mouse, hover the mouse cursor over the property, and then use Control middle mouse button up and down to scroll. You can see that we are scrolling using the edges as the direction of the cuts. Or we can use View, which uses the Cartesian. So basically, uh, bird's eye view, which is just XY. Okay, so whenever you look, so like that and like that. Okay, let's use tangent and line it up. So distance is kind of like remove doubles. So when you got two lines, when you got lines that are very close to each other, you can use distance to merge them. So you can see if I increase this, the line starts merging. So you can use this if the topology looks too busy and there are really close lines to edges to each other. You can increase this value to merge the edges. So most of the time I just 0.01, or for really busy topology sometimes I use 0.1, but that's already too much. So yeah, 0.01 is the perfect value for some of the cases. Okay, this one here, tangent, and let's select the proper. Um, you can use quad slice to prime the topology, then just fix the result. So we're going to get back on that. There we go. So right here we can fix this actually, and This is already quad, so we can get rid of this edge here. F9 and do not dissolve the vert. So this is already quad 1, 2, 3, 4. Much like this one. If you want to get rid of the triangle, F9, do not dissolve the vert. Also this one, F9, do not dissolve the vert. And this one, 1, 2, 3, 4. But if we don't dissolve the vert, the other verts are not dissolved also. So that's just remember that. Then Control X, select the verts, then Control X. And with this one as well, so do not dissolve verts. So I'm just showing you what you can do to repair the topology afterwards. But most of the time, I really don't bother getting rid of this. So a triangle is still okay for the random operators. They can still work. They can still work with tries, and yeah, because a trie can still be subdivided. So this is the most annoying part with Control X. It always defaults to dissolving the vertices. So you have to press F9 after the operation to bring up the redo panel. Get rid of this as well, and this, and this, and not that. Okay. We're going to keep this one because it's needed on this part here. Well, actually, we can separate an edge. So Alt V, and be sure that your mouse cursor is in the direction you want the split edge to go. There we go, and oops, keep it straight. Then we can get rid of this, and that becomes a quad. And this one also. Okay. Let's select everything. Shift G, and then T for type, and then apply mesh. Now they're real topology. Now we're going to reapply the mirror on the x-axis. Our let's make this our active object, and we're going to use the auto mirror on the active object. This will also work on the rest of the objects, but it will use the coordinates from the from the main object. But since they are already using the same space, so it's okay. So click on this part here. This part will be the real mesh, and this part will be the mirror geometry. Press X, and each one of them should be mirrored. So you don't have to select everything. Select the object individually, then use auto mirror. So now we can affect this dimension. So when you're mirroring near the symmetry line, I mean end setting near the symmetry line, that's I. By default, it's going to be like this. So to include the symmetry line, just press B to turn the boundary off. Now I can do this. Oh, I forgot the select everything again. And this is our main, our active object on a mirror, and the objects are already mirrored in the x-axis, so I'm going to mirror it in the z-axis. There we go. and let's just make them meet each other, and then XF to delete the face faces in the symmetry line. And in this view, we're going to, selecting this vert. I'm going to use the creative flow, add intersect object, cylinder, and alignment, and then size. So add intersect object adds objects. When nothing is selected, it adds the object on the 3D cursor's location. And when you have object selected, when you have faces selected or element selected, it will position the object, the cube of the cylinder, on the average location of all the verts in the selection. Okay, and this will also inherit the center or the origin of the active object selected. Yeah, when you use the operation. So I'm not gonna include the texturing in this video. I'm just gonna show you the workflow. So my design, my modeling capability really is um how do you say this? I think just entry level, because I don't really model all day. I script or write scripts and then model to, and then actually then I model just to test the script. So most of the time really I just think of and write scripts and not model anymore. Okay, what is this? I just noticed this oh, we're going to have to fix that. Maybe we can delete the line. There we go. So I don't know about the size of this. This looks too big to be a pistol. What's the size of the hand? So this is the handle, and this is the hand. 4, 5. One. Yeah. Um, and the other hand here. 1, 2, 3, 4, 5. Yeah, this could work. So we need to create the handle. Let's use this as the active object, because the creative flow cannot work without an active object. It needs an active object all the time. Okay, we're going to use number 4 for the draw shape, and that is strips. You can increase the size using Control AD and slow down the increment using Control Shift AD. So let's just figure out the thickness. And I'm going to press, you can actually already activate the mirror axis from here. So Z axis. That is our handle. Actually, we're going to make I'm going to make this shorter. Oops. Oh my god. Control. So before I'm selecting, I'm pressing Shift Z to activate wireframe, so I can actually select all of the vertices without needing to change angle, view angle. And let's get rid of this because this part is looking too curvy. I mean, looking too busy with all the angles. Oops. F, F, and F. And then delete this. There we go. Now it looks better with this size. So we're gonna actually add more to this. So the distance from the viewport to where the draw object is detected by this X here. So if I draw a circle, and you can reposition the that is actually called the origin or the marker. You can see it there. You can or I mean change its position using the place snap and or reset marker. So place C anywhere on the surface and shift C, it will snap to edges, faces, or vert. And alt C is, what is alt C? Reset marker. Oh, reset marker. Reset marker means that the marker will return to the original position in the draw. So in polygonal, it's in the second point. In the strips, it's in the second point as well. And in the circle, on the first point, and in the box, in the first point. Okay, so, but if you want to position the marker on the center of the active object, just press C in open space. There. We want it at the center because we're going to draw this object at the center line. And we want the thickness, control mouse drag, because we want the thickness to originate from that space. Now we have that. We can position it or subtract something. So with this new position, this part here becomes obsolete. So let's just remove it. So this is still using a modifier. Apply. And this is, oh, that's the real geometry. Auto mirror X and Z. Okay. Okay, this one as well. Apply mesh and to make everything. Let's just position the real geometry on the top as well, like that. And I can actually draw. Press T to cut through. And then I can do that, something of that nature. This is actually It's actually in gone, but we can just select the faces like that and use quad slice. Hmm. That's odd. You can use selected. I mean, nah, yeah, linked or all faces. So tangent and just selected. So when you're using Control R to create a loop, after the loop, you confirm it using left mouse button. You can press E and then okay, Control R. Oh my god, Control R. Uh, Control click and then you can select in the next operation. You can select the position. Press E and okay, you can see the red dot here. That means that this edge here is following this shape here. So we need to flip it. Now the red dot is here. Now it's copying um, the shape of this edge here. So we want that edge. We want that straight edge. Okay, there we go. Now we have the base of our gun. So for far away renders, you can this can already work. But we need to actually just bring it farther. Okay, let's try. I'm going to try slice. Look at that. Use this. The slice is actually a new operator. It's going to come in the next update. Limited. So and it's just a new way of creating cut lines, random cut lines. So it's another algorithm, and it kind of works like this. Oh, not quad slice. Random slice, and we have minimum length, minimum area, control the size of the cut faces, and we have this slide the minimum max. Basically, also defines the size of the generated box or rectangles, but in a different manner. So you can create those details. You can separate and oh uh yeah, I need to fix that. You can do that, or you can choose to render it as wireframe, and just decrease the thickness. Where are the thickness? Oh, okay. Move the offset. So just creates another way for you to create details. Okay, we're going to explore What random operator should we use? Should we use random panels? Okay, you can uh, select certain areas for detail and leave other areas for to be relaxed, or you can just, you know, overdo it. It's up to you. Let's get rid of the center line and create in the min max height, create some variation in the okay, let's just use this. Or random loop extrude. So random loop extrude is really good for creating the inner mechanism look. Let's just use either random panels or random loop extrude, maybe sometimes random cells, because you don't have this yet. In the making of this video, you won't have the random slice operator yet. Where is the subdivision? Oh, there's no subdivision because this is a random scatter. You can also use random scatter for detail. Offset. Where's the offset? Okay, maybe not offset. Okay, let's just use the random panels. If you want to immunize certain edges from the randomization, you can select the edge and then Control E, mark sharp, and use random panels. That will always be cut, but you have essentially removed it from randomization. Okay, let's immunize this. Mark sharp to avoid the bump distortion, and this one as well. And this property will also be in the next update. So there's a lot of quality of life improvements that I made. Let's immunize this as well. Actually, let's just, I'm going to just manually create the detail using mark sharp edges. Oops, marks, my god. Control E, mark sharp. Selecting this, I'm going to create a square. This will result in an in-gun, but doesn't matter. We're not using subdivision anymore because we're manually detailing the mesh now using mark sharp edges. We're not going to use subdivision anymore to run the panel, so it doesn't. We don't need the faces to be quads or tris. Mark sharp. So if I use random panels for this and 1%, 1%, you can see that the mark sharp edges has been cut. If you reduce this to 0% and also this, then along with the mark sharp edges, there will be randomization. You can also use the standalone panel cat add-on for this in my store, and this is solely dedicated to the mark sharp edges feature. So this is there is no randomization here. This will take all the mark sharp edges and turn them into panel cut details. Oops. Where is it? There we go. Okay, so you can manually draw the panel cut details using mark sharp edges. Okay, if the randomization is not giving anything that you want, you can just manually design it. Let's try random one more time. So those spikes that you see, those geometric spikes, sometimes they can go on to infinity. They can literally go on to infinity. But to fix that, in the next update, I'm introducing the inset mode. If you use non-even, this will get rid of the spikes. But there's a catch. So for example, a cube, and we use random panels. Okay. So if you use even for the inset, or increase. So this is what even looks like. And if you use non-even, this is what it looks like. Increasing the subdivision does not improve the bevel on the sides, because this doesn't work like normal bevel. And this is subdivision number 1. Look at the resolution on the sides. And this is subdivision 11. And basically, this is still the same ratio of topology in the sides. So that is the difference. So if you have spikes and if you're willing to uh, use this look right here, and you don't really notice this too much, then just use non-even inset mode when the update hits. We could use, actually, let's use random slice. This is going to be really not wireframe. Look at that. This made the gun look like a starship. Random tangent. Tangent means the longest. Tangent in my add-ons means the longest edge in the face. And that longest edge will be used as the direction. Okay. We can reduce the cut. So it looks good. Actually, this looks good. Oops. Um, too much. 100 and use even. If you don't mind the n-gons, then use the limited dissolve, because if you increase, as you increase the subdivision, the resulting mesh also becomes higher in topology. You can get rid of this using X limited dissolve, or during the operation limited dissolve. Since if this is hard surface, so you can just triangulate it and it will still work perfectly on any software that you export it to, or export, or yeah, export. I think we have margin. Yeah, I thought so. This is cut 6 and panel seed 1. Okay, we can try that. And here we'll introduce 0.01 in the max property, just to give some of the cells a different height. You can randomize the height, of course, using height seek. And let's try to use the vertex group. And when you, oh, wait, and toggle this off and use vertex group. If we use vertex group, this will be slower the higher the subdivision gets. But essentially, what this does is um, put the top faces into a vertex group, and these side faces here will be left alone. So selecting this vert, Shift G, vertex group, you can see that we've just selected the top faces, and if we invert, but curiously, if we go to here and use select, this will select everything. So there's I'm going to fix this before the update hits, but it works if you just use the viewport, click invert, Shift G and vertex group. So it works. So what this does is you can select these faces, then just apply random panels again, something like that, and you don't have to affect the side faces here, which are essentially too thin for the randomization. Okay, so you can keep you can keep this topology and then use it to your advantage. Create extrude or extrude out or in some detail. So when you're extruding like that, so don't just extrude it like that. In this angle, you can see it. So what I advise is use inset, then create some margin, and then inset up. And when you face it like this, you can see the detail. Same with going down. So just like that. Okay, so I want to create 3 insets for each of this. But if I press individual, it will inset the individual faces. So what I can do is inset. So remember the values that you've used. 0.003 for the margin and 0.01. Okay, negative 0.005, negative oh negative 0.001, okay, 2. So 0.003, negative 0.002, and just insert this, and F9 0.003 minus 0.002. So it's kind of annoying to do it individually, but I have no choice. 0.002. So just like that. Or you can create maybe some HUD right here. You mean HUD, user interface? Why is this so? I don't know. It's the topology. So you can definitely get rid of by just using the topology by just using after you finished making use of the quad topology, you can get rid of the rest of the faces using limited dissolve. And if you want triangulate, or better yet, use the modifier triangulate. That is the beauty. Okay, what is that? Okay, it's creating some distortion. So essentially, if you want to make your triangulation modular, you can use the um triangulate modifier. But if you don't, even if you don't use the triangulation, you can press Control T to triangulate. You can still get rid of the same topology using X and limited dissolve. So normally I just leave it like that because in render, it's going to render these faces like this anyway. It's going to triangulate that in renders. And this is just available for you as in-gone in the 3D viewport because you are essentially in the modeling phase. Okay, the in-gone is provided to you because you have the ability to model it. But in render, it's like this. Okay, let's try the row I. Let's try the random panels here. Oh, it's not symmetrified, or mirrored. This part here, X, Z. There we go. On cylinders, if you use too much subdivision, especially when you go past 1, you can already see the banding. You can get rid of this bonding by using limited dissolve, but of course, you make it an ingon. But in the new update, there's a new operator that will arrive to get rid of the bonding. But the only caveat is it doesn't work all the time. It works on simple meshes, but let's see if it works on this. So essentially it's extras. No, it's not extras, it's in mesh. Clear bonding. Oh yeah. That doesn't work on this. Yeah, so this is still work in progress, but you can already use it on simple objects. But for this type of topology where everything is too close to each other, it's probably gonna fail. So for this, we're either going to just use subdivision 1, or if we want to go past subdivision number 2, we're going to use limited dissolve to keep the faces smooth and avoid the bonding. Okay, let's just use subdivision level 1. So again, this is, in this video, most of this will be, the resulting topologies will all be separate. So this is a non-destructive workflow. So in the next video, I'm going to demonstrate to you the destructive workflow where you can merge the result of random panels or plate insets to the mesh and create a unimesh instead of having these objects right here. You can model some manually and then select some areas to be detailed with the add-on. And make sure to balance your detail and don't use too much. Create rest areas for the viewer. Let's just draw the So my advice to you when you're modeling is repair later. Model the topology first, then repair the topology later. Instead of model and repair as you go, that will be, I think, slower. So for this type here, I just, of course, maybe I should have just extruded, I mean, inserted like this. But essentially, I draw it first. I created the topology first, then I can repair it by triangulating this area here. But for something like, for example, this one right here, it's in this part here. So the inset cannot do that, but we're just going to repair the topology afterwards. Selecting these ingun faces, triangulate F9, oops, triangulate, then Alt J, and then F9 for the redo panel of the Alt J, which means tries to quads or quadify, and set this to 180. Okay. Let's clamp it. So Control B to bevel and press C to clamp so it doesn't go past the bevel threshold. See? But that means that there are doubles on this part here. So select everything and then M and then merge by distance. Whoa, 49 vertices? Oh, this is a separate. Okay, don't do that if panel results and loop extrude results. So Shift Z and then select the SID vertices or the I'll press Shift Z to go to wireframe and toggle X-ray, so I can select all the vertices. When I'm not in X-ray and just select this, I'm just gonna select one of them. So yeah, and then M by distance. So removed 3 vertices, 1, 2, and 3. And if we move this, there's no more doubles. So it's up to you. In texture mode, it's up to you whether you can use this as a UI or a screen for anything that you could display. And also this one here, you can also use this for UR or just anything you can use it for. And then we come here. We're still going to use random panels because this is the most, random panels is actually the most, why is it? Oh, I'm going to add additional topology for this. So remember, the result of the random operations are dictated by or affected by the topology. So whatever the shape of the topology, the resulting shape, the shape of the topology affects the shape of the result of the randomization. It didn't go. Okay, so when I use loop Control R to add a loop, it doesn't. I don't have anything to choose from the shape flipping. I want a straight line, so you can actually just draw it with the knife. Press A for the slice. To snap it to. Press A to snap it into angles. Then press C to cut through. Then you have that. Or you can add the loop, and since this is mostly angular in the XYZ axis, we can scale it in the Z axis and then press 0. And then we can add the additional topology. So adding the additional phase loops, you can we can add it like this, then press E and follow the shape of this edge here. Or you can select this and Control B to bevel. Okay, let's just position it right here. Then Control B to bevel, and then use the middlemost button, scroll down or up to increase the resolution. So like that. Okay. Now our random operator will have enough topology to work with. Okay, this is kind of this one here. I'm just gonna fix this. How do you fix it? I don't know. You made it. You fix it. W, loop tools, flatten. There we go. And for the other ones, you can adjust manually. So for me, topology first before repair. Yeah. Also applies to topology first before design. Design first before topology. Damn. Yeah. Sorry about that. Design first before repairing the topology, not topology first. So it's easier to repair than Actually, this one's a little bit more chaotic. So before you confirm, watch out for this geometries. So my bad on that one. Well, let's use random panels on this as well. Let's use random loop extrude, non-even. So that's what non-even looks like. If we use even, it's going to, but we can avoid this by playing around with the global seed. That, or if you can get rid of the spike using the even inset mode, then you need to look for the edge that's causing the spike. Then you can, in a contiguous manner, beginning from that edge, you can mark sharp those edges to immunize it from the randomization. Okay. Random panels. So we're still using radial. So walk is a bit more chaotic, and is I use walk mostly for loop extrude. So we can see here that the edges here, somewhere here, and the edges somewhere here, or a vert is causing this a spike. But let's see if we can get rid of it using just the, no, actually the bumps are actually not. So this usually happens in this type of geometry. This sharp turn here and this vert here that has one, two, three, 5 edges connected, and with part of it like this. So it's usually going to create the spikes in those areas. See? Sometimes it also does it on that area. Non-even gets rid of it completely. So let's just use radial. So this is actually just the way inset reacts to this kind of topology. That means that it can't be helped. Okay, so what we can do, however, is besides immunizing, we can just stop it on this part. Just select the, okay. Just select the part. That's still, okay. Let's stop right there. Okay. There we go. And then Alt A, because those faces are still selected. Then we can select this one next. Let's add more topology. And then this one is next. The mark sharp, I forgot if you already have this. I think you already have this. Let's increase the minimum. Besides the random seed, you can also play around with the there we go with the panel size to affect the shape of the result. And this one, this is the main body, and we're going to detail this also using the same technique, but we're going to create a lot more expanse or rest areas here. I'm going to teach you about the notches in the um next videos. For now, what we can do to get rid of the spikes is just play around with the panel set until it's gone. Or do the same thing that I showed you before. So what I'm looking for right now is the something that will look good for the rest of the other randomized objects that I made. So we've mostly just used the random panels for this project, but I have demonstrated a few of some of my modeling tricks to you, so that's good. Modeling tricks that does not include the add-ons, of course. Okay, this one here. Let me try and show you a bit of the why the let's create additional topologies for this. Okay, so starting off, I can yeah, I'm just going to select a pattern that I like. For example, select this one. I like this one. Okay, but I need to add something more to this, like right here, right there. So instead of giving me this geometry, I can just use this mark sharp only, and it gives me this. It also the mark sharp. Maybe I should get rid of the UV as well. Yeah, I should get rid of that. Wait, Control E, clear seam. Yeah, I'll just get rid of the seams to make it less confusing. So these are mark sharp edges, and this is the result of the. Remember that when you immunize the edge from randomization by by them by mark by getting them marked sharp, it also uh it immunizes them from randomization, but it also cuts them. Okay, so I need something like this one here. I'm going to oops, mark sharp, and I also need something here. Oops, Control E, mark sharp that, and draw cuts. Mark sharp, and then selecting everything. Random panels, you can use panel cut or random panels. For random panels, just increase. If you want just the mark sharp edges, then you can just increase the min max of the panel size to 100%. That means no randomization, just the cuts. Decrease the distance of the. Okay, there we go. Now our cuts have been. Oh, it's probably too close to the center. Has been included. And then we're going to draw object R panel 1. Get rid of this. We don't need it anymore. Alt H. There you have it. Just in case you want additional design, do the cut edges or the randomized edges. Okay, I think we'll finish here. It doesn't look too detailed or too busy. Still looks good. Close up, mid distance, and far away. So you can keep the base mesh for something that's really, really far away. You don't need these geometric details. You can just render it as or something like that. Okay, you can just render the base mesh. For close up and mid, then you will use the result of the randomization. Now, before I end this video, I'm going to select all of the mesh and add a base color, which is going to be just gradient, gradient values. Random vertex color, black and white. Okay, so how to set up black and white. Objects saturation is 0. Min max is 0. And then value, the lowest, the darkest one will be 0.7. And this will be our brightest one. And we're going to set the vertex color for each of the face islands in the mesh. So face islands corresponds to, for example, this one. Each of these islands here. So when you use random panels or random loop extrude, it's not, the mesh inside is not really welded together. You can use L to select the whole island, like that. You can go to, if you go to vertex mode, you need to hover over a vertex to press L. If you don't hover over the vertex, it still works. Okay, they probably changed that. So for 100% efficiency, just use press 3 to go to face mode and press L. L, just like that. So we're going to use island and create a different vertex color per island. There we go, our done. So if you want in the comment, you can say in the comment if you want the next video to be all about texturing this from the start. But I'm still going to use my grand shaders, of course. Just so if you want to look at my texturing shading process. Okay. So this is it for this video. I hope you learned something from it, and I hope to see you next time. If you have any questions, be sure to use the comment sections or the link in the description of the video. And that is it, and I hope you have a nice day.